One last thing I want to look at before we move on to our types of reactions is how we categorize acids and bases. And we categorize them on the basis of strength. Now, when we hear that term acid or base, a lot of times it gets a negative connotation because it's like, oh, it's super dangerous. We don't want to touch it. And that might be true for some, but if you really take a step back and look, you're consuming acids and bases um, in your foods, in your drinks, all the time. I mean, if you ever had any salad dressing with a vinegar base, vinegar is just a solution of acetic acid in water. So you're, as I said, you're dealing with these on a daily basis and don't even know it. It's coming in contact with your skin, you're digesting it, and I should say ingesting it, and it doesn't have any adverse effects. And so really what determines the dangerous nature of an acid or a base is its strength. And that refers to how much does it react. A strong acid or base reacts completely, but a weak acid or base only partially reacts. So what do I mean by completely, partially? Let's take a known strong acid like HCl. We put HCl in water, it reacts completely to form hydronium and chloride. Now, I want to emphasize that reaction arrow that I drew. We haven't really talked much about the reaction arrow, but notice that it's a one-way arrow. And that means all reactants or all HCl becomes the products. And here's an example. This picture kind of gives a diagram. We took some HCl and we put it in some water, mixed it up a little bit, and you'll notice that there are no HCl molecules in this solution. It's all chloride and hydronium. So all of this HCl was consumed in the reaction with water. And that's what makes HCl a strong acid, is that every single bit of it will react. Now let's contrast that with what does weak mean? Well, weak means that it's just an incomplete reaction, that you put it in water and not all of it reacts. You still have some of the original acid floating around. So for example, acetic acid, which as I said earlier is the main component of vinegar. It's just it's a little bit of it's dissolved in water, and that's what vinegar is made of. And it only partially reacts with water. And you'll notice I kind of got this weird looking arrow, this half arrow going in either direction. This is called an equilibrium arrow. Now we will go a lot more in depth in the equilibrium later. I don't want you to worry about it right now, but that's the arrow that we kind of use to indicate that the reaction is not complete. So only some of this acetic acid reacts. And in fact, if we were going to quantify it, you don't need to know this, but just to give you an idea of how drastic it is, only about 1% of all acetic acid molecules, when you put it in water, will react to form hydronium. And so this picture kind of gives you an example of what that looks like. So we took some acetic acid, put it in water. Notice here we still have the original reactants and just a little bit of the products. So only some of the acetic acid actually reacted with the water, and that's what makes it a weak acid. Now, let's take a look at the most common strong acids. And I would like you to know these. So HCl, HBr, HI. Notice it's all the halides except fluorine. Okay. HF is not on that list because HF is a weak acid. And then we have HNO3, nitric acid, perchloric acid, and sulfuric acid. So these are all oxyacids. But what's the common theme between all of them? And to give you a little bit of hint, what I want you to think about is look at how many oxygens there are and compare them to other polyatomic ions that are similar to them. All of these have the maximum amount of oxygens in the polyatomic ions. Like nitric acid is a strong acid. Nitrous acid, HNO2, is not a strong acid. Perchloric acid is a strong acid. But if you went to like chloric acid or chlorous acid, those are not strong acids. So these are oxyacids with the most amount of oxygens in the polyatomic ion. All right, now what are weak acids? I'm not going to go in depth in that because there's so many. What I want you just to know right now are strong acids. And then how about strong bases? The ones I want you to know are all group 1 and group 2 metal hydroxides. When I say group 1 and group 2, I mean the first two columns of the alkali metal, or not the alkali, first two columns of the periodic table. So like sodium hydroxide or potassium hydroxide or barium hydroxide and so on. Those make strong bases. And again, what makes them strong is that when you put them in water, they completely dissolve to form hydroxide. If you take NaOH, put it in water, that is a one-way reaction. It completely dissolves into sodium ions and hydroxide ions.